Okay. Okay. So the polynomial of degree 3 or more leaves a remainder of 1 and -9 when divided by x minus 2. Okay, so how I do this, right, is, okay, first, from this is very similar to a lot of the practice set also. So here it tells you that if I substitute x equals to 2, right, f of 2 will be equals to 1 based on this part, red color. Okay, so should I call you Maddie? I call you Maddie. Wow, that's a cool name, eh. Wow, I didn't know you called this. Okay, Maddie. Okay, so that means this one and this one will tell you that if I sub f of -3 is equals to -9. So far, okay?
Yeah.
So, okay, this same polynomial, the same polynomial now, if I write it out in division algorithm, dividend is equals to divisor multiply by quotient. So quotient, I don't know what is it. Yeah, I'm just going to leave it like that. Okay, plus remainder. The remainder is ax plus b. Okay, the remainder is ax plus b. So because okay, Melly, you see the remainder, the divisor is quadratic, which means that the remainder can be linear lah. Fair or fair. Okay, so the same polynomial now, right? We know that if we sub in -3, we are supposed to get -9. Okay, this is all perfectly derivable by you. So what is new? What's the new thing? You must see the relationship between this and this. They are actually connected. They are actually connected.
So
Okay,
like if you factorize, it's like x minus 2x plus 3.
correct. So this one, if I factorize, right, is x plus 3, x minus 2.
Oh, then
So
it will cancel out the quotient.
correct. So the
Oh, okay,
you don't
okay.
have to worry. So that means, okay, if I sub x equals to -3, right, it's supposed to be -9 plus, which is equals to, I sub -3, right, -3a plus b. That gives you equation 1. If I sub 2, right, it's supposed to be 1, but that's also equals to 2a plus b. That's equation 2. Equation 1, equation 2. Then you solve for a and b simultaneously. The most important step is to connect this together with this one and this one. Oh, x squared plus x minus 6 is actually equals to x plus 3 multiplied by x minus 2. Okay?
Is the answer 2 and -3?
The answer is coming soon to theaters near you. Okay, it is 2 and -3. Correct. Mm. Mm. Okay, people enter waiting room. Oh, okay.
Mr. Tan, can I ask a question from the revision package?
Can. I just make sure your co-hosts are also your add people. Okay. Yasmin, what question you want to ask?
For topic 5 to 6,
Okay,
question 2, question 5, question 7, question 9.
Okay, wait. Okay. Question.
Question 2,
Question 2. Question.
5,
Question 5.
question 7,
Question 7.
question 9, part 2 and 3.
Part 2 and 3. Okay. And okay.
Then, yeah.
Okay. Start from question 2. Question 2. Okay, so show that for all values of k, the let me see. Uh maybe let me go to the side. Okay. Let me go to the side. Yeah, add a page. Okay. Okay. Okay, so then A. Hey, what happened? Okay. Question 2, okay, can see, okay, so show that for all, show that for all values of A, okay, so now we are going to go through revision package, quiz 2 revision package, question 2, okay, quiz 2, question 2, okay, so this one, we want to show that y minus 1 cuts the curve at y equals to x squared at two real and distinct points. So what this says is that we will basically want to show that the discriminant is more than 0, right or not? Cannot? We want to show that the discriminant is more than 0. So which means that we want to first show that when we solve y minus 1 equals to kx, that is equation 1, followed by y equals to x squared, equation 2. This solution, this equation will have discriminant more than 0, right? So we want to show that when we solve simultaneously, when we solve, right, the discriminant should be more than 0. So that's what we will do. Okay, with that, from equation 1, can I say that y is equals to kx plus 1? Cannot, Jasmine? Can I? Then after that, I sub equation 3 into 2. Right, so if I sub 3 into 2, kx plus 1 square is equals to x squared. Okay, I continue. K square x square plus 2kx plus 1 minus x square equals to 0. So far, okay? Cannot. Now, I compile together. I have k square minus 1 bracket x square plus 2kx plus 1 equals to 0. This is my equation. Okay, the idea is that I have to put it in the form of ax squared plus bx plus c. And then from here, I can actually find my discriminant. So my discriminant, I know that it's supposed to be more. I want to show you that it's more than 0. B squared minus 4 AC. This is the same as B squared minus 4k squared plus 4, which is just equals to 4. My discriminant is 4. It is more than 0 for sure. So I have shown that my discriminant is more than 0. What does it mean? So what I have shown this, that I have shown you that my discriminant is more than 0. This tells you that therefore there will be two distinct and real roots. Okay, there will be two distinct and real roots. So far, okay? Yeah,
Wait, Mr. Tan,
I might move very quick. So if you need to, Yasmin, you can wait for the video recording or you can like screenshot or so. Okay.
wait,
Yeah.
Mr. Tan, why is it kx plus 1 square?
Why is it kx plus 1 square? Why is it kx plus 1? Oh, why is it this one? Why is it 2k,
Yeah.
2kx plus 1? Because I'm expanding this.
But I thought you sub it into equation 2 and like equation 2, for equation 2 is just y.
For yeah, oh, you're right. Sorry. Yeah, shit. Okay, so I wrong already. Erase. Okay, so from here, I sub y, right? Y is kx plus 1 equals to x squared. X squared minus kx minus 1 equals to 0. I find my discriminant, b squared minus 4ac. This is the same as k squared plus 4, which is also more than 0 for all k. So I also show you that my discriminant is always positive. That's mean okay, ma? Sorry about it. Can I? Okay. So question 2 is done. Okay, so I just go down to question 2.
Tan, can you please go through question 4?
4, 13, and 14. Okay, 4, 13 and 14. 13 and 14. 13 and 14. Okay. So question 4. Question 4. Okay. Okay, next one, question 4. Oh, question 4 is okay lah. So question 4 basically is like that. Okay, when we talk about gx more than fx, right, we are saying that we want the y value of g to be more than the y value of fx. Okay, so question 4 goes like this. Okay, if we want question 4, if we say gx more than fx. Now imagine gx as a y value, fx as a y value. Right? So we basically want the y value of gx to be more than the y value of fx. We want the y value of gx to be more than the y value of fx. Correct or not? So from here, what do I, how do I, okay, so from here, right, how do I go about doing it? Is that, okay, so I see that gx, fx, okay, where will gx be more than fx? So if my gx, right, is this blue color line, my fx is this pink color line, right? I'm really trying to see where is my blue more than my pink. Right? I'm trying to see where is my blue more than my pink. So if you look at this region here, now where is the blue going to be more than the pink, right? Is this part here. This part here. Can you see? This is the portion where x is between -7 to -4. -7 to -4. Your gx is above fx. Your blue line is above the pink line. Does that sound fair? Okay, sorry, what was this question? I lost already. Okay, fair, okay. So can I say that the pink is above? There's also this part here, right? Where x is more than 3. That's when my pink is above the blue. Sorry, that's when my blue is above the pink. All right? So we want to see where is the blue above the pink. The blue above the pink here is where we want gx more than fx happens, right? It happens for x between -7 and -4 and the value of x to be more than 3. So it's basically these two ranges. Okay, it's basically these two ranges. Okay, ma? So that is the answer for question 4. Simple as that. Simple as that.
We need to combine them together, like negative, like we can just write x must be more than 3 and less than negative.
Oh, sorry, it shouldn't be n. It's a or. It's a or.
Oh, okay.
It shouldn't be a or.
Why is it?
Sorry?
Is it because there are two? Okay, yeah, I got it.
Because if it's n, it's the intersection. Or that means it can be both. It can be either. It can be either. It can be either. Huh? So it's not an and, it's an or. When there are two sets, we say it's an or. Okay. Okay, next one, I go to question 5. I go to question 5. Okay, I go to question 5. Okay, question 5. Question 5. Okay, find the exact range of values of m such that mx and the curve intersect. Intersect means what? Intersect, it could be more than 0 or more than equals to 0 or equals to 0. So when they say intersect, it could be what? It could be 1 time, it could be 2 times, right? So basically, they want to tell you that if mx plus y equals to 2, equation 1, y equals to -x squared plus mx minus 1, equation 2, correct now? Okay, so this intersection, the discriminant is supposed to be more than equal 0. Okay, so from here, sub equation 1 into 2. So from equation 1, I can also say that if I relate this, I can say that y is the same as -mx plus 2. I call this equation 3. Next, I will solve simultaneously. I sub equation 3 into equation 2. -x squared plus mx minus 1 equals to -mx plus 2. Okay. So from here, then I put together lah. I rearrange. I make right hand side 0, x squared minus 2mx plus 2 plus 3. This is my equation. Okay. So then I check my discriminant. Discriminant, this is b squared minus 4ac, which is the same as for b square is wrong. Salah. B square is negative 2m squared minus 4ac, which is the same as 4n squared minus 12. Right, so we need this, we need discriminant to be more than equal to 0. Because we are talking about intersection. We are talking about intersection. Okay, ma? We are talking about intersection. So from here, 4m squared minus 12 more than equal 0. Divide by 4, I have m squared minus 3 more than equal to 0. I factorize m minus square root 3, m plus square root 3 more than equal to 0. Right? If you don't feel safe, you draw the graph out. Right? So this is negative square root 3, square root 3. We are looking for the left and the right hand side, which tells us that the answer should be m less than negative square root 3 or m more than equals to square root 3. So far, okay? And all? Okay, so that would be for question 5, part 1. So question 5, part 2. Now I look at this one, right? Okay, so you see, we hands is a hand. So very easy one. Hands okay. So we look at y equals to negative x plus 2 and y equals to negative x squared plus x minus 1. If I look at this, right, okay, the thing is, when they say hands, right, hands means what? We need to use the part 1 to help us. Okay, if we look at m, basically, this and this are connected. M, y equals to negative x plus 2, if you relate to mx plus y equals to 2, this is basically the case where m is equals to negative 1, right? M is equals to negative 1. So part 2 and part 1, I say again, if I look at part 2 and part 1, part 2, right, and part 1, this is the case where your m is negative 1. So if m is negative 1, right, based on my solution here, if m is negative 1, right, where will how many intersections will I have? So I can see that if m is negative 1, right, does it lie in this range? Does it lie in this range? Does it lie in this range? Okay, so if we look here, we know that from part 1, from 5 part 1, m, if it's negative square root 3 or less, or m, which is more than 3, right, will tell you that there are two real roots, or there are two equal roots. Right now. So, but if think of the opposite, if m is between square root 3 or negative square root 3, the opposite, what does it mean? It means that there are no real roots. Right now. So which one does m equals to negative 1 lie in? It lies in the, which one will it lie in? It will lie in this part. Right now. So for this case, right, for part 2, right, for part 2, since you're talking about m equals to negative 1, right, which lies in this range, right, I can tell you there are no real roots. No real roots basically means what? There are no intersection. There is no intersection. So far, okay? There's no intersection at all. There are no intersection at all. Okay, it's basically the case where m is equals to negative 1. Okay, the number of intersection is just 0. Number of intersection is 0. Okay? Can So that is 5 part 2. Who asked for question 5? Have I satisfied you? I mean, are you good with my solution? Are you happy with my explanation? Okay. Can Okay. The rest of you, if you don't mind, just on your video, if you want to ask question. Okay. The speaker draws strength from the crowd. Okay. Question 7. Okay. Question 7. Okay, so I just check. Have I question 7? Okay. So question 7. Find the range of values for. Jingyu, the practice set answer, I believe, inside the WhatsApp chat. You help me check. Okay, the practice set answer is inside the WhatsApp chat. Okay, so question 7. Question 7, Question 7. Okay. Y equals to kx squared. This is equation 1, right now. And ky equals to x squared plus 1. That's equation 2. Right? For I want them to meet. I want them to meet. Meet could be what? Meet can be meet 1 time. It can be meet 2 times. Basically, it means that I will want the discriminant to be more than equal 0. Right? So if I look at this, right, how do I find the discriminant? So first, definitely I need to equate lah. I need to equate. Also, I'll equate them. So if I equate these two, then this is k. I sub in. I'm going to sub kx squared here. I'm going to sub in here. So this is k of kx squared equals to x squared plus 1. Right? Basically, I solve 1 and 2 simultaneously. Now next, this gives me k squared x squared just by simplifying both sides. Right? As per all equations, I like to make one side 0. So I'm going to push one side to be 0. K squared x squared minus x squared minus 1 equals to 0. This is the same as k squared x squared. X squared k squared minus 1 equals to 0. From this equation, you can see my a is k squared minus 1. That's the coefficient of x squared. My b is 0. My c is negative 1. I look at the discriminant, b squared minus 4ac. This is supposed to give me 4k squared minus 4. Okay, so I need this to be more than equals to 0. I need this to be more than equals to, we need this to be more than equals to 0 because we are saying that we want them to meet. We want them to meet. Meet can be meet 1 time, can be meet 2 times, which is why I have more than equals to, I have more than equals to 0. So my next step is to solve 4k squared minus 4 more than equals 0. This gives me, divide by 4 on both sides, k squared minus 1, factorize, k minus 1, k plus 1 more than equals 0. I draw the curve. Right now, this is negative 1 and 1. We are talking about the left and the right, which is k less than equals to negative 1 or k more than equals to 1. So that is the answer for question 7.
Mr. Tan,
Yeah.
the answer in the revision package say it's k less than -1 or k more than 1.
So I'm not done yet. Okay, so from here, right, why is it we need to reject negative 1? So the reason very simple. What happens if k equals to 1? Right? Plus minus 1. You see, it's very scary one. So here, if you see, what happens if k is equals to plus minus 1? Okay, let's example, if k is equals to 1, right? You will notice that means here we have y equals to x squared. And here we have y equals to x squared plus 1. Now you think about these two, can they ever meet? X squared and x squared plus 1. They cannot meet. Yeah, they cannot meet, which is why the k cannot be 1. Okay, which is why the k. So this inequality is like, it's not even seen, right? We have to actually look at the equation just like log, just like search. We sub it back to the equation. We find that, all the answers don't seem to make sense, right? Because if k is equals to plus minus 1, basically the two solutions cannot even meet. The two curves cannot even meet. That's why we add to the condition that k cannot be equals to plus minus 1, which is why we get k less than minus 1 or k more than 1. Okay, now I reached the end of my explanation.
Wait, Mr. Tan, I don't get what you mean by that the both curves cannot meet if it
So
is
if you see
one.
like k equals to 1, right, you will have y equals to x squared and y equals to x squared plus 1. So y equals to x squared will look something like this. This is y equals to x squared. Y equals to x squared plus 1 looks something like that. Okay, it looks something like that. That's why you see the two curves basically cannot touch each other. 对吗? But to be fair, I feel this question very hard. Yeah, a lot of people cannot get didn't get the minus 1. Why we must reject? Okay. Okay, just give me 1 second. I'm just checking my Zoom. See anybody chat me anything. Okay. Okay. Question 7, done already. Okay, so next one, question 9. Okay, who asked for question 9? Quick one. Okay, who asked for question 9? Quick one. Who asked for question 9? Sorry. Question 9. Okay, so question 9, okay, basically is that student council. Okay, so student council like to sell balloon, right? Okay, so part 1, you're okay, huh? Part 1, you're okay. So you think about it, right? Okay, so if I look at the graph, right, it's as though my y is negative 80x plus 1380 lah. Okay, 1380 is as though if I don't sell any, I mean, it basically is the y-intercept. Okay? Correct, the y-intercept. Okay, basically what happens if I sell the balloon for free? I don't even charge anything. Then I'm going to sell 1380 balloons. So if I aim to collect a revenue of at least 5500, right? What does this mean? Okay, what do I mean by revenue? So revenue, right, basically means the number of balloons you sell multiplied by the selling price. Okay, so I just want to say that your revenue, right? Your revenue would be the number. Okay, question 9. Question 9. Okay, revision package question 9. Okay, so it will be the number of balloons sold. The number of balloons that you sold. Okay, it multiplies by the selling price. The selling price of each balloon. So revenue does not refer to profit. Okay, you haven't minus profit, or you haven't minus your cost yet. Revenue minus cost, then you get profit. Okay, so revenue is just what you collect in. Right, you haven't minus off the rental, all those things. Okay, so number of balloons sold, what does it mean? The number of balloons sold, right, would be none other than the function itself. Right, the number of balloons sold is this function. So that is negative 80x plus 1380. This is the number of balloons sold. What is the selling price? The selling price is X, right? Where X is the selling price. So using just very humble algebra, I have showed you that your revenue can be expressed in the form of an algebraic quadratic expression. Okay, now what do I need, Yasmin? I will need my revenue. We will need this to be more than 5,500. I will need this to be more than 5,500. So from here, expand it out, negative 80x squared plus 1380x minus 5500 more than equals to 0. This is the quadratic expression that you are aiming to solve. So far, so good? So far, so good. Now, I like to make things positive. So I'm just going to multiply everybody by negative 1. Then I get 80x squared minus 1380x plus 5500. And you solve this inequality. You solve. Okay, if all goes well, you will reduce until you have 4x minus 25, x minus 11 less than equals to 0, which tells you that your x must be between 11 and 6.25, right? So in this region, right, if your x is in this region, you are guaranteed your revenue is at least 5,005. Okay, so how did I start off? So at least 5,005 just based on this answer here. Okay, if x is between 6.25 to 11, it guarantees that your revenue is at least 5,005 because we formed the expression for revenue and we solve an inequality using the revenue function. Okay? Can all?
But why can't it be like x is more than or equal to 6.25? Why is that like together and not an or an and?
Why is it larger than n or not equal? Can be equal. Can be equal.
No, I mean like, why is it not separated? Why is the inequality together but not like separated as an or and?
Okay, so because for this, right? Okay, so for this, right? Okay, so the fundamentals will boil down to the graph. when I look at this inequality, right? When I reach this inequality, what will I do to solve the inequality? So first, we draw out the graph. Right now, we draw out the graph. We know that this is positive x squared, right? Right, positive x squared. It means that it's a happy phase. This is the graph of 4x minus 25 versus x minus 11. The intercepts would be 6.25 and also 11. Now we are looking for what? We are looking for less than equal to 0, right? So we are looking for this part. The region where it is between 6.25 and 11 will tell you that it is less than equal 0. Okay, that is why we are looking for the bottom part. We are looking for the bottom part and not the top part. Okay? Can I?
Mr. Tan,
Yeah.
can you go through like 11 IVA?
Okay, IDA, huh? Can I?
Yeah.
Okay,
And question 12, D and E.
okay. 主要
And question 13.
question 13, okay. Question 13, I highlight already. Okay. Okay, so slowly lah. Give me, then do be patient with me. Okay, can So if I'm not going through the question that you want, just feel free to multitask. Okay, can Okay, so now I'm going to go through question. Okay. Okay, so question 9 over already lah. Okay, question 9.
No, you have not done part 3.
Is it? Oh, yeah. Sorry. Okay, question 9, part 3. Oh, okay. So how to find the selling price that will maximize the revenue? Okay, so we know that the revenue price, what will it look like? Okay, so the revenue, we know just now, the revenue price, right, is supposed to look like this, which is negative 80x squared plus 1380x. So far, okay? Can you just factorize this. This looks something like this. It looks like x bracket 1380 minus 80x. Okay, this graph, right, is a set phase graph. The graph looks like that one. There are two intercepts. One is 0, one is at the point 17.25. Okay, this is the graph, the revenue graph. This is basically the revenue graph. Right? So if I want to so-called maximize the revenue, what I'm trying to do is I'm trying to maximize means big, right? Means big. I want to find the biggest revenue possible, which is the X that can give me the biggest revenue. Right? Obviously, we want to have more money, more revenue means more profits, right? So which part they are actually asking you for the turning point? They are asking you for the turning point, the maximum point. Okay, they're actually asking you for the turning point. The turning point is the one that you are looking for. So in a situation like this, right, how do I find the turning point? Well, that's easy, right? Just take 0 plus 17.25 divided by 2. And we will get our x to be, let me see, I think it's what, 8.625, 8.625. Okay, so I know that when x equals to 8.625, right, that will provide the maximum revenue. Okay, then I will sub x equals to 8.625 into the revenue function. So my revenue function looks something like that. Negative 80x squared, so it's negative x squared, 80x squared plus 1380 times 8.625. I find this, if all goes well, your answer should be 5951.25. Okay, so I'm answering this part. The money collected from the maximum revenue is this. Okay, the selling price, oh shit. Okay, the selling price is this. This is the selling price. Okay, this X here, this will be the selling price. This is the selling price. This is the selling price. This is the maximum revenue. This is the maximum revenue. So far, okay?
Wait, Mr. Tan, where do you get 17.25 from?
when I draw the graph out, right? Okay, when I draw this graph, right? Okay, you basically equate to, I want to find the two x-intercept, right? Okay, I will equate y to 0. So from here, I go and solve x 1380 minus 80x equals to 0. By the zero product rule, this tells you that x equals to 0, or 1380 minus 80x equals to 0. This means that 1380 equals to 80x. This means that x equals to 1380 divided by 80, which gives you 17.25. So 17.25 and 0, they are the x-intercept. Okay? The very granular part of it. Okay, can I? Now from here, then what do I go about doing next is sorry. Okay. So with that, I'm done for question 9. Okay. Well, next, I'll be going down to question 11. So question 11 is a race start by Ashley. Ashley, are you okay with 11 part 1?
Yeah,
Part 1 is okay. Part 2 is okay?
yeah.
Part 3 is...
Wait, but I don't know if my graphs are correct.
You don't know if your graphs are correct. Hey, do you all have the revision package solution? You all do have, right?
I don't think they have the full solution.
You all don't have the full solution.
Yeah.
No, then I think you sent it to the group chat already. So I
Oh.
think the solutions, like the full one.
Okay, yeah, I think so.
Okay.
Let me just send you again, okay?
Okay. Thank you.
Yeah, it's coming soon to theaters near you. I just got it somewhere. Wait. 301, 305. I just send one more time. Okay, so you can see again.
Thank you.
Okay. Okay, very good. So now I will go on to question 11. Question 11 is not easy, not easy. Okay, so I'm going to go very slowly. Okay, so first, okay. Okay. X squared, 3x squared minus 6x plus 5. It looks like this, right? So after you do completing the square, I believe your answer for part 1 should look something like this. After question 11 part 1, question 11 part 1. Okay, this should give you y equals to 3x minus 1 square plus 2. Okay, so from here, I mean, basically, the graph will look something like this one. After you do part 1, it will look something like this one. So 1, 2, right? 1, 2, if you recall from JH2, right? They are your turning points. Okay, so they are your turning points. So that's what it looks like. So 1, 2, they are your turning point. Now, on the same set of axes, you draw y equals to negative x minus 2. So, I think I won't go through like how to draw quadratic graph. I think you all should know better than me now. Also, but I can tell you the graph it looks like that one. Very cute one. They don't touch one. Yeah, okay, they don't touch each other. Okay, so this is the y-axis. The graph of x minus 2 it won't look like this. It legit looks like this. Okay, this is 0. This is I believe 2, right? And the turning point is 1, 1. This is the graph of y equals to negative x minus 2. This is the graph of y equals to 3x minus 1 square plus 2. Okay, so you see two graphs. Okay, of course, you when you draw that time, I do understand that it's definitely not easy because you don't know, like you're not sure how to label out the axis or this, but just follow your steps into drawing a quadratic graph, right? Write down the intercepts, find the turning point, right? Sketch the shape out. Okay, or you will get marks for that. Now, part A, the range of values for x for which negative x squared plus 2x, which is the graph in pink, is below the graph in yellow. The graph in yellow is over here. The graph in yellow over here. Okay, the graph in yellow. But pink must be less than yellow. Pink must be less than yellow. Okay, so the thing is, I ask myself this. Now if I look at this, when is my pink less than my yellow? Isn't it all values of x will give me the pink below yellow, right? Yeah, so that's why my answer, right, is basically all values of x. Any value of x, right, will have the graph of x squared plus 2x. You will have your graph of x squared plus 2x below. Okay, you will have the graph of x squared plus 2x below. Any point, you can see anything here, right, will have my negative x squared plus 2x below the yellow graph. Right, all values of x, no matter where I go, right, my pink is always below yellow. So the answer to part A is all values of x. Okay, all values of x. Right now. So if you see the solution, they put something like x is all real values. That's fine as well. Okay. Now the thing is this. Now they ask you, instead of the original pink graph, right? Now they ask you now, okay, what about, just now I have my negative x squared. How about negative x squared plus 5? What will happen is I plus 5. So what will happen here is that now, if you have a plus 5, okay, the graph will look something like that. Okay, the graph will look something like that. So the graph, right, is basically going, let me just show you all first before I draw. When you have, this is negative x squared minus 2, right? Okay, if I add, it's going to go up like that. It's going to go up this way. It's going to go up this way. The whole graph is going to shift up by 5 units. You're basically adding by 5 units. All the y coordinate will add by 5 units because I'm adding 5. This is negative x minus 2 plus 5. Take note, it's a plus 5. Here got no plus 5. Here got plus 5. The whole graph will shift their y values up. It's like moving house like that. Some of you like to move house, right? Move up by 5 units. It will go up by 5 units. So you see 1, 1 will become 1, 6 because the y coordinate plus 5. Okay, 2, 0 will become 2, 5. 2, 0 will become 2, 5 because I do a plus 5 to the y unit. 0, 0 will become 0, 5 because I add by 5 units. So far, okay, ma? So I'm talking about 11B. I'm talking about 11B. So my entire graph will just shift upwards. It will just shift upwards. Okay, this is the whole graph. It will shift upwards. Here, this is going to be the point 0, 5. 1, 1, add 5 units will become 1, 6. 2, 0 will become 2, 5. Now you compare this graph, right, versus negative x squared plus 2x plus 5 is this one. Is this guy over here. Oh, shucks. Okay. The guy in blue. Okay. This is the blue guy. This is the, oh no. Okay. This is the blue guy. The guy in blue is over here. This is the guy in blue, right? Blue over here, right? Yellow is here. Yellow is here. Yellow is here. Okay. Oh, yellow is here. Yeah, yellow is here. When is your blue more than your yellow? Okay, you can see that for blue to be more than yellow, right? The answer is that x must be between 0 and 2. X must be between 0 and 2. That's the answer. Sorry. Less than. My bad. Less than, it means that we want this part and this part. It means that we want x less than 0 or x more than 2. Okay? This part, x more than 2. X less than 0 here. Okay, so quick check. Shout out to Ashley. Are you satisfied? So far, does what I say make sense to you?
Can you explain as all values of x part again?
Okay, if I look at the pink and the yellow, right? The pink and the
Yeah.
yellow. The pink is here, right? The yellow is
Yeah.
here. Can you see that no matter which x value I take, my pink is always going to be less than yellow. My pink is always going to be less than yellow. Pink is here. My pink is here. Pink is here. No matter what
Yeah.
So my x value is here, x equals to 0.5. Y value is less than yellow. Here, I'm still underneath it. When I say less than means I'm underneath. I'm underneath the yellow graph. No matter where my green graph is, right? I'm underneath my yellow graph. Fair?
Oh yeah.
So the answer is all values of x. So
Mm.
like I think I'm less than the yellow graph. Oh,
Yeah, okay, thank you.
okay. So next I'll talk about part C. Part C is even more exciting. Okay, find the range of k for value of k for which x equals to 1 is a solution to this. So this graph, I know that if I plus k, right, I need it to be more than equal, but I can only have one solution. I can only have one solution. What does it mean? Hey, my graph like that, how do I need to, if I plus k, right, I'm supposed to shift up by k units. I'm supposed to shift up by k units. For example, this graph, right, I need to shift up by k units. I know, since I'm adding a k here, I need to shift up by k units, right? By k units so that I can go upwards. What's the value of k I should add? The answer is very simple. Look at the y coordinate here. This is y coordinate 1. Y coordinate 1. This is y coordinate 2. Right? You just want the graph to touch each other. Right? You just want the graph to touch each other. So I'm going to use green color now. Basically, I just go up by 1 unit. This is y equals to negative x minus 2 plus 1 plus 1. Can you see? Plus 1. So you do a plus 1 here, plus 1. You go up by 1 unit. As long as your k is equals to 1, the graph shifts up by 1, you can see that there is a point. Oh no, there is a point of intersection, which is here. X equals to 1. This is the solution, which is the point of intersection. This is a point of intersection, right? A point of intersection between the two graphs. Between the two graphs. So far, okay? Ashley, okay?
Yeah, thank you.
Okay, next one, I will go through question 12. Question 12. 12, D, right? So D is over on my left-hand side. I'm just going to continue talking. So for those, if I am not going through the question you want, please just feel free to multitask, okay? Don't worry, don't need to pay attention to me all the time. Your time is equally precious as well. Okay, so when I look at this, right, okay, one trick I want to show you is actually this guy, right? This guy, can I say that this is the same as log x to the power negative 1? Can I say that?
Yeah.
Can I say that therefore this is the same as negative log x?
Yeah.
Can I?
It's -1.
Correct. So the question just simplifies to 2 log 2 plus x less than equals to negative. Ayo, what happened to my iPad? Okay. My iPad throwing tantrum. -1. Because this is
Yeah.
just negative. So from here, divide by -2 on both sides. I have to be more than half. So what I'm doing is I'm dividing by -2 on both sides. I'm dividing by -2 also. So I'm more than half.
Yeah.
Dividing by negative sign switches my inequality. After which,
Yeah.
just continue, right? Change it to index form. So here to here, I change from log to index form. No big deal. No big deal, right? No big deal.
Yeah.
The base is more than 1. This means that x would be more than equals to square root 2 minus 2. Okay, more than equals to square root 2 minus 2. This is looking at 12D. Okay?
Okay.
So, but the thing is, we also must note that okay, our x here, because x is part of a base, right? This means that we also need x to be more than 0. Right? At the same time, here this tells us that x more than 0, x cannot be 1 because x is a base. Right? So you need to take the intersection of all these, right? The intersection of all these is just x more than 0, x not equals to 1. So far, so good.
Wait, so basically if it's a base, then like it has to be more than 0, but it cannot be 1.
Correct. This is the restriction. Remember, log is like your good friend who has this particular diet. Or the base cannot be 0, must be more than 0 and cannot be 1. And
Okay.
just give me 1 second. Sorry, I multitask. Just open the solution document. Okay. Okay, can. Okay, next one, I go to 12E. 12E, yeah. Okay, 12E. 12E log 0.1x. This one is a nice question to do. 0.1x less than 1. Now, from here, remember, okay, if you want to change the log form to index form, right, x, right, will be more than 0.1 power 1. So just be careful. The reason is because the base is less than 1. Don't you remember, any time, right, when the base is less than 1, right, there's always, you need to be very careful. The inequality sign will switch. Yeah, so from here to here, that's it. That's the answer already. Yeah. Okay,
So basically, like the base always has to be more than 0. So it like the equality sign have to switch, right?
Correct. If it's more less than 1, the inequality sign has to switch. If the base, right, if the base is between 0 and 1, this one will tell you that you must switch. Okay? The reason is because if log ax, right? Okay, if a is more than 1, it's increasing function. If a is between 0 and 1, it's a decreasing function. Okay?
Okay.
Okay, so next I will go to question 13. Question 13. Okay, question 13, I believe, is a request by Afia and Maddie, right? So here, this is a very nice question to do. So let's look at e power x log 5, 3x minus 5 plus e power x log base 5 of x less than 0. We are looking again, for those who just came in, revision package, topic 5 to 6, question 13. Right, so how do we solve it? First of all, we must understand that e power x is this very special friend. He is like me, right? We always very positive one, okay? So e power x is a very positive function. You know that e power x looks like that. If I factorize out, you see it looks like this. And e power of x is always more than 0 for all x. Is always more than 0 for all x, which means that we can just cancel it off. It doesn't give you any answers. So my solution, right, just reduce to log 5. If I use the product law, I can put them together. This just reduce to this, right? Since e power x offers no solution, it is more than 0 for all x. From here, x 3x minus 5 is less than 5 power 0, which is equals to 1. From here, x 3x minus 5 minus 1 is less than 0. Because this is equals to 1, also less than 1. 5 power 0 is 1, okay? So what I'm doing again, just want to share in case you lost it. 5, I bring over, right? I bring the 5 over. I change the log form to index form. Remember the woodcutter story I told you all? So 5 power 0 over here is equals to 1, right? And from here, solve 3x squared minus 5x minus 1 less than 0. Solve. Yeah, let me just play cheat using the answer. Okay, so from here, the answer is not sexy, because I'm looking at a solution because not that I can mentor some, but I look at the solution. You know that the answers looks like that. It's pretty disgusting. Your x is 5 minus square root 37 over 6, right? Found by quadratic formula, square root 37 over 6. Why do I have to go do this? Because question says exact. So I cannot use calculator. All right. So here, with these two answers, I draw the graph. My answer is supposed to look like this. 5 plus square root 37 over 6. 5 minus square root 37 over 6. Okay? Can all? Can all? So from here, how do I go about doing next? Is that I also need to consider that this part tells me that I will need x to be more than 0. This part tells me that I will need 3x minus 5 to be more than 0, which is x more than 5 over 3. Now, children, do consider 1, 2, 3. You need all 3 to be fulfilled because you are looking at a log inequality. All 3 must be fulfilled. The final intersection, right? If I need to fulfill all 3, 1, 2, 3, the final intersection of all 3 using the number line, this will give you 5 over 3 x and 5 plus square root 37 over 6. Okay, ma?
Mr. Tan, can you explain the part where e to the power of x goes to nowhere?
E to the power of x, right, is always positive. So it's like a number that I can just divide off. So if you see, for example, here, right, this is positive, this is positive. Okay, if something times something is negative, right, and this is positive, right, that means this part has to be negative. E power x is always positive, which means that I can just divide it away. There's no answers.
So where does e power x goes?
You can divide it away. So I can divide by e power x on both sides. 0 divided by e power x is still 0. Okay? Okay, so next, where's Maddie? Maddie, okay, question 13. Okay, so next I will go through question 14. Wow, question 14 looks so disgusting. Okay, let me see. Okay. First of all, I can draw log x. Okay, y equals to x plus 0.5 log 0.5. This is the same as log 0.5 of x plus 0.5 of log 0.5. Okay, so this is basically a line. This is a line where your gradient is log 0.5, right? The one in yellow. And the y-intercept is 0.5 log 0.5, which is basically, the one in beige. Okay, this is what I have here. So from here, okay, log 0.5, we know how to draw. Log x, we know how to draw. Log x will look like that. Very nice graph. X goes down. Okay, sorry, I never draw very nice. I tried my best. Okay, I'm trying to do it fast. If I talk too slowly, then I become very boring. Then you all won't listen already. Okay, so y equals to log x. Y equals to log x. Okay, this one. Okay, log x. So the intersection, right? The intersection is basically 0.5 log 0.5. Where would that be? It's probably somewhere here. Okay, the point will be somewhere here. Right, so you just need to calculate 0.5 because this is 1, 0.5 will be somewhere here. Log 0.5, log 0.5 is actually negative. It's actually less than 0. So 0.5 log 0.5 is somewhere here. The graph will go somewhat like this. It'll go somewhat like this. Sorry, wrong. It'll go somewhat like this. This is what the graph will look like. Okay, this is the point when it intersect. This is the graph of y equals to log y equals to log 0.5 x plus 0.5 log 0.5. Like that. Okay? This is just a graph sketching question. Hence, solve the inequality this, right? Inequality log x of minus 0.5. Okay, so now next one, I look at the question. question states that we're supposed to solve this, right? Okay, so x more than log x log 0.5 minus 0.5, right? Okay, what I can do, I multiply by log 0.5 on both sides. I multiply by log 0.5 on both sides. I will have x log 0.5 log x minus 0.5 log 0.5. The inequality sign switches. Why? Because this guy is a negative number. This guy is a negative number. Can you just take note of this? This guy is a negative number. Okay, so because it's negative, now you see, right, from here, okay, then I'm going to shift this over to the right. This will be x log 0.5 plus 0.5 log 0.5 less than log x. Then when I read this part, I realize that, isn't this the graph that I draw? Didn't I draw this? You like to doodle, right? I like to doodle too. Didn't I draw this? Then I look at this one. Didn't I draw this? Didn't I draw this already? Isn't this the line that you draw? Fair enough. So these two are already drawn. Okay, I already draw these two. That means I'm basically looking for the brown graph which is here, to be underneath the yellow graph. The yellow graph is here. Now, where is my brown underneath the yellow? Where is my brown underneath the yellow? So you see, the brown is underneath the yellow, basically on this side. Sorry. Oh no. Okay, so the graph basically is underneath the yellow between this part. Here. Can you see? Right, the moment this is x equals to 0.5. At this part, x is 0.5. So the answer, right, is when x is more than 0.5. Your answer is fulfilled. This is fulfilled already. Okay, right? So who asked this question? Is it Effie and Maddie? Or I'm actually not sure. I didn't write name down. So far, okay, ma? This is question 15. Okay, I hope I still have you. Please feel free to clarify in case I talk to. I'm also recording now, so I will share this with you all later.
Wait,
Mr.
Mr. Taki? Oh,
You
Sorry.
say first, you say first.
oh, okay. Like, can you repeat the whole thing, the whole question for thing, and like how you even got that graph, and then
Okay. Ashley, you like? Actually,
For topic 7, can you go through question 4?
topic 7, question 4. Let me just write down.
Topic 7.
Mr. Tan, for question 14, why is the graph linear? The graph that I got was quadratic.
Oh,
Yeah.
actually, you wait, sorry, what I said. Topic 7, question 4, you mean assignment, is it? Or oh no, revision package, huh?
Yeah.
Okay. Okay, chill first, Okay, let's go to the start. Okay, so if you look at this, right? Yeah, go back to the start. Okay, if you look at this graph, this graph over here. Okay, this graph over here, this graph, right? And log x plus 0.5. Okay, I simplify it to this. Okay, you see, I simplify it to this. This one. This guy, right? If I expand x times log 0.5, 0.5 log 0.5, is actually a linear line. It's actually a linear line. Okay, ma? It's actually linear. So I was saying just now that this is a linear line. Okay, so F here, I want to ask you, this one negative or positive? Log 0.5. Log 0.5.
I'm guessing positive.
Okay.
No idea.
So no worry, no idea is fine. No idea is the perfect answer I'm looking for. When you tell me no idea, then I got a job. Okay, so log graph goes like this. Okay, this one is 1. This one is y equals to log x. This is x, this is y. You see this region, right? 0.5 is here. Now you look, okay, 0.5. You look at the y value. Is it positive or negative? This is log 0.5. Is it negative or positive?
Positive.
Okay, you see the y value here is underneath the
Negative, sorry.
you see negative. Okay, so basically, if you take log x, right? But if this x is between 0 to 1, then your log x is going to be negative. Okay, so far, that's one thing you must appreciate. If x is more than 1, then it will tell you that your log x is positive. Okay, so far? Don't make sense, I feel? No. Okay, can you tell me what you are bothered by?
For the part, right? Why is like you said that log x will be more than 0. The log x is y, right? As in y equals to log x is more than 0.
Okay. Let me say. Maybe I never say properly. Okay, let me say again. Okay. Y equals to log x. If I draw the graph out, okay, so you see I draw the graph out like that, right? This is 1. Okay, this part, right? Can I say that here x is more than 1? Then you look at the y value. Is it more than 0 or less than 0?
More.
More. That means, can I say that when x is more than 1, your log x is more than 0?
Yes.
Can I say that here, when x is between 0 and 1, your log x, your y value is negative?
Yes.
And this is something that you can appreciate. So that when you see log 0.5, can you tell me straight away, is it positive or negative?
Negative.
Negative. Why do you say negative?
Because the coordinates are below the x-axis.
Okay, because 0.5 is less than what? Is less than what? Less than 1. Yeah, less than 1. Okay. I ask you again. Tell me the answer within 3 seconds. Log 3, positive or negative?
Positive.
Log half, positive or negative?
Negative.
Log base 5 of 0.2, positive or negative?
Negative.
Log 7 of 0.9998, positive. Sorry?
It's still negative.
Very good. Okay, very good. Okay, so now I come back to this. Okay, now I come back to this, right? Can I say that this is a negative gradient? So this part, can you see that is basically a line where this is the gradient. Sorry, this is the gradient. This is the y-intercept. Can you see a mx plus c? Can you see a c there?
Yes.
Do one more time. This is the m. This is the x plus c. Can you see?
Yeah.
Oh, steady not? So that means, right, you know that it is a line. It is a line because it's linear. So the line actually looks like that because log 0.5 is negative, right? Log 0.5, this is downward sloping. It is downward sloping. Okay, so this is the line that I draw. This point here, right, was provided by the question. So the question stated that the point intersection, the point intersection at the point intersection between is this one. This is the point intersection. Given that the point intersection between the graphs is this. Boleh then log x very easy to draw This one you just draw like that. Okay Fair fair. Okay, so from here, hence I solve the equation this part again. So now so far okay? Okay, following So when I solve this inequality, so Janelle, what I will do is I write it out like that. I divide both sides by log 0.5. Okay, I get from here to here. Sorry, not divide, I multiply. This one multiply, I cancel off. I get log x from first step to second step. Okay, show you. I multiply by log 0.5. Okay, then I shift 0.5 log 5 to the left hand side. Then I see, isn't this drawn already? Isn't this drawn already? Right now. So I'm just basically looking for where my line is below the log graph. I'm looking for where my line is below the log graph. Okay?
Hey, Mr. Tan,
Ah,
the inequality sign switch because like the log 0.5 is negative, right?
correct.
So
Precise.
basically, if it's like multiplied by like a negative number, then the equality sign should switch, right?
Perfect. Correct.
Okay, thank you.
That's right. Okay, so I'm done with question 14. Janelle, can I just check satisfied ma? Can to my explanation works for you? Okay. I feel okay? Ready, okay? Okay. Wow, Jing Kai very good. Jing Kai on camera. Okay. Okay, so next one. I go to 7. Topic 7. Topic 7, question 4. Oh my god. Okay, let me see. I haven't prepared this yet. Topic 7, question 4. Give me a second. I throw 2 sandbag. If both sandbag land inside the smaller circle, give me a second, sorry. If both sandbag land in the smaller circle, the player wins a big toy. If only one sandbag land inside circle X, I win a small toy. The player would not throw the sandbag beyond the larger circle. A is I win big game, B is I win small game. Okay, so maybe what will I do? Okay, so I need to throw 2 sandbags. I throw the first sandbag. Okay, I will either land in X or I will land in Y. So, okay. So what's my probability of landing in the... Oh, it's given that A union B prime is 9/16. It's given that A union B prime is 9/16. What does that do for me? 9/16. A union B prime. What does A union B prime means? Okay, A means I win big toy.